Okay, now I would like to explain the problems on magnetic field intensity. Okay, the problem: a wire of length L is formed into first A circle, second one B equilateral triangle, and third one C square. For the same current I, find the magnetic field intensity H bar at the center of each. So here conductor type is line conductor and the length of the conductor is L meters. Three cases. Now we have to find the magnetic field intensity at the center. So first one circle, second case equilateral triangle, third one square. So first case one. Okay, first a wire of length L is formed into a circle. Okay, y total length equals to L. It is formed into a circle with radius equals to R. So we know that circle circumference formula 2 pi r. Here radius equals to r. So circle circumference equals to 2 pi r. So length of the conductor is L meters. So 2 pi r equals to L. So r equals to L by 2 pi. R equals to 0.1591 L. This is the radius of the circle. Here L length of the conductor formed into a circle. So 2 pi r equals to L. Finally r equals to this one 0.1591 L. So next we have to find the magnetic field intensity at this point. So center of the circle. So consider a differential length of the conductor dl bar. This is differential length of the conductor dl bar, which is perpendicular to the radius vector r bar. So we know that according to Biot-Savart's law formula, the differential magnetic field intensity dh bar equals to idl bar cross ar bar by 4 pi r square, or another formula idl bar cross r bar by 4 pi r cube. Okay, here r bar equals to r bar by modulus of r bar whole cube, modulus of r bar. So dh bar equals to ideal bar cross r bar by 4 pi r cube, or dh bar equals to ideal bar cross ar bar by 4 pi r square. So next to find this one dl bar cross ar bar. So dl bar cross ar bar equals to, we know that a bar cross b bar equals to ab sin theta into normal unit vector. So similarly dl bar cross ar bar equals to modulus of dl bar modulus of ar bar into sin theta into normal unit vector. So this is normal to dl and ar bar vectors, an bar vector is. So sin theta value, sin theta equals to 1. So here the angle difference between r bar vector and dl bar vector equals to 90 degrees. These two are perpendicular. So theta equals to 90 degrees. So finally modulus of ar bar value equals to 1 and modulus of dl bar equals to dl. So idl bar cross ar bar equals to idl into an bar. So dh bar equals to idl an bar by 4 pi r square. So next the total magnetic field intensity h bar equals to integral dh bar, integral dh bar. So here integral dl. So integral dl equals to total length of the circle. So total length of the circle equals to 2 pi r. So integral dl equals to 2 pi r. So finally h bar equals to I into integral dl bar equals to 2 pi r. So 2 pi r into an bar by 4 pi r square. Or it equals to I by 2 r into an bar. R equals to L by 2 pi or 0.1591 L. Okay, substitute R value. So finally we get h bar equals to 1 by 0.3182 L an bar. So units are ampere turns per meters or amperes per meters. So next second one, a wire of length L is formed into a equilateral triangle. Let the triangle is placed in xy plane. Okay, we are placing the triangle in xy plane such that center at the origin as shown in figure. Okay, this is the equilateral triangle. So here AB equals to BC equals to CD. So we know the total length of the conductor equals to L meters. Total length of the conductor equals to L meters. So that conductor is formed into equilateral triangle. So here AB equals to BC equals to CD. It equals to L by 3. Total length equals to AB plus BC plus CD. It equals to L. And AB equals to BC equals to CD equals to L by 3. So this is the midpoint. Okay. And we are considering this conductor in xy plane. This is x-axis, next one this is y-axis. So now we have to find the magnetic field intensity at this point. So consider a differential length dl, differential length dl at point P at a distance of x from D. Okay, this is the midpoint of AB. So consider point P at a distance of x from point D. Okay, here length of AC length of AC equals to L of AC equals to L by 3. So L of AD equals to L of AB equals to also L by 3. L of BC equals to L by 3. So L of AD, here D is midpoint of AB. So L of AD or length of AD equals to L by 6. So next to find length of CD. Okay, length of CD equals to AC square minus AD square. So AC equals to L by 3, AD equals to L by 6. So we get length of OD equals to 0.2886 L. So next, from the property of triangle, this is equilateral triangle. The property of equilateral triangle, the L of OD equals to 1/3 of L of CD. OD length equals to 1/3 of length of CD. So find OD length, it equals to 1/3 into CD length. 1/3 into CD length, it equals to 0.0962 L. Okay. So next we have to find the magnetic field intensity at this point. So consider a differential length. This is differential length at point B at a distance of x from the point D. Okay. We know that the magnetic field, differential magnetic field intensity, dH bar equals to IDL bar cross R bar by KIDL bar cross AR bar by 4 pi R square. So by using this formula, first we have to find differential magnetic field intensity. Next, by integrating, we can find the total magnetic field intensity. So first write R bar vector, the distance vector between differential length to origin. So dl bar vector, R bar vector equals to, okay, this distance equals to x and OD length equals to 0.0962 L. So R bar vector equals to minus x into ax bar plus 0.0962 L into ay bar. Okay. This is x-axis direction, next it is y-axis direction. Here first one, this vector plus this vector equals to R bar vector. This vector equals to minus x into x bar, and this vector length of OD equals to 0.0962 L, and this direction is y-axis direction. Upward direction is y-axis direction. So into ay bar. So finally R bar vector equals to this one, minus x into x bar plus 0.0962 L into ay bar. So next, modulus of R bar equals to square root of x square plus 0.0962 L whole square. Unit vector AR bar equals to R bar by modulus of R bar. So it equals to R bar by modulus of R bar, AR bar vector. So next one, DL bar vector. Here DL bar vector equals to, this is differential length vector, DL bar equals to dx into ax bar. It is parallel to this AB side, parallel to x axis. So on AB, the differential length equals to dx and direction x axis direction. So DL bar equals to dx into ax bar. Next, find DL bar cross AR bar. DL bar equals to dx into ax bar and AR bar vector. Okay, this is AR bar vector. So first AX, AY, AZ, DL bar, AX bar component dx, AY bar component 0, AZ bar component 0. So next AR bar vector, AX bar component equals to KX bar component value equals to minus 6, and AY bar component equals to, okay, here find DL, not this is DL bar cross AR bar, DL bar cross R bar. Okay, DL bar cross R bar first find. So DL bar cross R bar vector, AX bar component equals to minus x, AY bar component equals to 0.0962 L. Next, AY bar component equals to 0. So finally DL bar cross R bar equals to this one. Okay, DL bar cross R bar equals to this equation. So next, the differential magnetic field intensity, dH bar equals to formula IDL bar cross AR bar by 4 pi R square, or IDL bar cross R bar by 4 pi R cube. Here we are using formula IDL bar cross R bar by 4 pi R cube. AR bar equals to R bar by modulus of R bar. Okay, use that formula. So finally DH bar equals to, so I into DL bar cross R bar, this total DL bar cross R bar divided by 4 pi into here R cube. So R cube is there. Okay, modulus of R bar equals to root of x square plus 0.0962 L whole square. So finally R cube, in denominator R cube is there. So x square plus 0.0962 L whole square whole power 3/2. Okay, this formula IDL bar cross R bar by 4 pi R cube. Okay, by using that formula, we are finding differential magnetic field intensity expression. So next to total magnetic field intensity expression, H bar equals to integral dH bar. Here limits. So first we are finding the magnetic field intensity due to AB set. Okay, this is midpoint. So origin, this is midpoint of AB. So total length of the AB equals to L by 3. So this is origin. So at this point is 0 and this point is minus L by 6. This point is plus L by 6. So here limits are minus L by 6 to plus L by 6. So limits are x equals to minus L by 6 to plus L by 6, or it equals to 2 into x equals to 0 to L by 6 dH bar. Okay, this can be written like this. It equals to 2 into I 0.096 to L by 4 pi integral 0 to L by 6 dx into Az bar by x square plus 0.0962 L whole square whole power 3 by 2. So next let x equals to 0.0962 L into tan theta. So dx equals to 0.0962 L secant square theta into d theta. So next find limits for x equals to 0. X equals to 0, theta equals to 0, x equals to L by 6, theta equals to 60 degrees. Just to substitute here x values and find theta values. At x equals to 0, theta value equals to 0. At x equals to L by 6, theta value equals to 60 degrees. So next h bar equals to psi into 0.0962 L by 2 pi integral 0 to 60 degrees 0.0962 L into secant square theta into d theta Az bar by 0.0962 L whole cube into secant cube theta. So it equals to I by 2 pi into 0.0962 L. So integral here secant square theta by secant cube theta. Okay, secant square theta by secant cube theta 1 by secant theta. 1 by secant theta equals to cos theta. Integral cos theta equals to sin theta. Limit 0 to 60 degrees into Az bar. It equals to 0.866 I by 2 pi into 0.0962 L Az bar. So finally it equals to 1.432 by L into I into Az bar. Okay, this is the magnetic field intensity at the origin due to AB set. So the triangle having 3 sides. So total magnetic field intensity equals to H total equals to 3 into H bar. It equals to 3 into this one. So 4.296 I by L Az bar ampere turns per meters. Okay, next third one. So wire of length L meters formed into a square. So consider XY plane and said that center is at the origin. So consider the differential length dx at point P. Okay, dx at point P at a distance of x from x from this point. Okay, midpoint of AB. So here length of the conductor equals to L meters. It is formed like a square. So AB, CDA, sides of the square. Here AB equals to BC equals to CD equals to DA. So each side length equals to L by 4 meters. Now we have to find the magnetic field intensity at this point. We are considering here Cartesian coordinate system XY plane. This is x axis. Next one, this is y axis. Okay, this origin point is midpoint of the square. Now we have to find the magnetic field intensity at this point. So consider a differential length dx at a distance of x from this point. Okay, midpoint of AB. So the differential length to origin or midpoint vector equals to r bar. This r bar vector equals to this vector plus this vector. Okay, this axis x axis, this axis y axis. So this vector equals to minus x into ax bar. This total length CB length equals to L by 4. Okay, here origin is midpoint. So origin to this point length equals to L by 8. So r bar vector equals to minus x into ax bar plus L by 8 into ay bar. Okay, first one r bar vector equals to minus x into ax bar plus L by 8 into ay bar. So next one modulus of r bar. Modulus of r bar equals to square root of x square plus 0.125 L whole square. Next find unit vector ar bar equals to r bar by modulus of r bar. Okay, this one. So next find dl bar cross r bar. Okay, not this is dl bar cross ar bar. It is dl bar cross r bar. So dl bar vector equals to dx into ax bar. Next r bar vector equals to this one. So find dl bar cross r bar. Unit vectors are ax bar, ay bar, az bar. dl bar vector ax bar component equals to dx, ay bar component 0, az bar component 0. So next to r bar vector ax bar component minus x, ay bar component 0.125l, az bar component equals to 0. So dl bar cross r bar equation. So we know that the differential magnetic field intensity expression according to Biot-Savart's law, ideal bar cross AR bar by 4 pi r square or ideal bar cross R bar by 4 pi r cube. Here we are using formula ideal bar cross R bar by 4 pi r cube. So I into dl bar cross R bar equals to this expression, okay, divided by 4 pi r cube, okay, 4 pi r cube, 4 pi r cube equals to, so modulus of r bar equals to this one, so r cube equals to x square plus 0.125 whole square whole power 3 by 2. Okay, so square root of x square plus 0.125 whole square whole cube, it becomes x square plus 0.125 whole square whole power 3 by 2. So next find the total magnetic field intensity h bar equals to integral dh bar. Here limits are, okay, here limits are minus L by 2 to plus L by 2. Okay, this is the origin point. So this distance equals to L by 8 and this distance equals to L by 8. Total length equals to L by 4. So limits are minus L by 8 to plus L by 8. So integral minus L by 8 to plus L by 8 dh bar, or it equals to 2 into integral 0 to L by 8 into dh bar. So it equals to 2 into I into 0.125 L by 4 pi integral 0 to L by 8 dx into az bar by x square plus 0.125 L whole square whole power 3 by 2. So next to let x equals to 0.125 L into tan theta. So dx equals to 0.125 L into secant square into theta. Next find limits. So first at x equals to 0. So substitute x equals to 0 and find theta value 0. So theta value equals to 0. So next to substitute x equals to L by 8. So theta value equals to 45 degrees. So finally h bar equals to 2 into I 0.125 L by 4 pi integral 0 to 2 pi 0.125 L secant square theta into d theta az bar by 0.125 L whole cube secant cube theta. It equals to 2I by 4 pi into 0.125 L integral 0 to 45 degrees cos theta into d theta. Secant square theta by secant cube theta 1 by secant theta, it equals to cos theta. So integral cos theta equals to sin theta, limit 0 to 45 degrees. So finally h bar equals to 0.9 by L into 0.9 into I by L into az bar. So this is the magnetic field intensity at origin due to AB side. Okay, here the square having 4 sides. So total magnetic field intensity equals to 4 into h. So it equals to 4 into 0.9 by L into, okay, 0.9 into I by L az bar. So h total equals to 3.6 into I by L az bar ampere turns per meters or amperes per meters. Okay, here we are finding the magnetic field intensity at origin at 3 different shape of conductors. So first shape circle, but length of the conductor L meters. So second shape triangle shape, so length of the conductor same L meters. So third case square shape, here also length of the conductor equals to L meters. In these 4 cases, by using Biot-Savart's law, we are finding the magnetic field intensity at origin.